Hi students, this is our tutorial number 6 for the solution concentration series, and in this tutorial we will talk about how to perform dilutions. It's a common laboratory practice that we have solutions which are having higher concentration of solute and are referred to as concentrated solutions, and we need some solutions with lower concentration of solute, dilute solutions. So we have solutions with higher concentration and we want to make or prepare solutions with lower concentration of solute. There are some terms involved. For the sake of calculations, these solutions with higher concentration of solute are commonly referred to as stock solutions, and solutions which we need or we want to work with, they are referred to as required solutions. And a simple equation is used to calculate the amount of stock solution which is required to make the dilute solutions, and that equation is normally just like this, that we have stock, we have required, and stock is actually the concentrated solution and dilute solution is what referred to as required, because we require dilute solution, that's why we are taking it as required solution. C1, V1 represents stock, and C2, V2 here represents required solution. Represents mean that C1 is actually the concentration of the stock solution, and V1 is the volume of the stock solution which will be required to make our desired solution. Similarly, C2 is the concentration of the required solution and V2 is the volume of the required solution. Volume could be in liters, milliliters or microliters, and similarly this concentration may be in molarity, normality, percentage, formality, osmolality or any other concentration term. This equation sometimes is also written as M1V1, M2V2 or N1V1, N2V2, M1 for molarity, N1 for normality. So generally we are using here C1 and C2 to represent the concentration of the stock solution and required solution. One important point to be noted here is that whenever you are performing these dilution calculations, keep in mind that the concentration units which are used for the stock solution must be same as concentration units required for the desired solution or the dilute solution. Means to say both sides of the equation should have same concentration units. For example, if you are requiring a solution with a known molarity, then you must enter molarity of the stock solution. If you don't have molarity, if it's in percentage of or it's in some other concentration term, then you first need to calculate the molarity and then it will be put. Similarly, the volume on both sides of this equation must have same units. If it's required in liters here, you will get answer in liters here. If you put milliliters here, you will get answer in milliliters here. We will elaborate this whole concept with the help of 3 examples here, and these examples are related to molarity, parts per million and percentage of different solutions. So this is our first example here, and this is about parts per million in dilution, and according to the statement of this question, how will you prepare 200 ppm solution of glucose in 500 ml if you are provided with 1000 ppm glucose solution. So the data given in this problem is that we have stock solution here, 1000 ppm. This is our stock, and concentration is 1000 ppm, so this could be the C1, and our required concentration is 200 parts per million solution of glucose. So 200 ppm of glucose is our required concentration, which I've written as C2, and then we have volume of required solution, 500 ml, so this is our V2. So putting all these values here, C1 V1 equals C2 V2, or we need to calculate actually V1 volume of the stock solution required to make this desired solution. So we'll put C2 here, and C2 is 200 parts per million, and V2 is the volume, 500 mils, and then concentration of the stock solution is 1000 ppm C1. Putting all together here, ppms will be cancelled, and 25s are 100. So 100 ml of stock solution, 1000 ppm glucose solution, will be required to make this solution. So in order to prepare this solution, first of all we need to understand how much volume, 500 ml we need. So we will take a flask which is measuring flask actually, and we will transfer 100 ml of this stock solution in this very flask, and then we will add water to make up total volume of the solution up to desired volume, which is actually 500 ml. So this is how the solution will be made actually. Two steps. First of all, we need to calculate how much volume of the stock solution is required to prepare this solution. We have calculated using this formula, C1V1 equals C2V2, and putting all these values here, we are getting 100 ml of the stock solution. And then how to make this solution? You will prepare this solution by taking a measuring flask of 500 ml, because our final volume is 500 ml. You will transfer 100 ml of the stock solution to this measuring flask, then rest of the measuring flask up to the 500 mark will be filled with distilled water. Now this new solution is your required or desired or diluted solution. It has a concentration of 200 parts per million glucose solution. Our second example about dilutions is about molarity. And in this very question, you will have to prepare a solution with a lower molarity than the stock solution. And the question is how you prepare 0.1 molar solution of sodium hydroxide in 250 ml if you are given 2 molar sodium hydroxide as a stock solution. So our stock solution has a molarity of 2 molar. Our required solution has a molarity of 0.1 molar, so it is C2, that is C1, and the required volume is 250 ml. So you will use this equation here, C1V1 equals C2V2, and we need to calculate V1 here. Putting all these values, 0.1 molar is our required concentration, 250 ml is the required volume, and 2 molar is the concentration of the stock solution. So calculating all these, we get 12.5 ml of the stock solution required to make this very solution. Second step would be how to prepare this solution. So you will take 12.5 ml of the stock solution, which is 2 molar sodium hydroxide, from this very container. You will take 12.5 ml and you will transfer this to a flask. The flask will be a measuring flask of 250 ml. So stepwise, you will take a flask, measuring flask of 250 ml, you will transfer 12.5 ml of the stock solution into this measuring flask, and then you will add water to make up the volume up to 250 ml. So your total solution volume will be 250 ml. This is our third example in which we have a stock solution with a weight by volume percentage concentration, and said what volume of 30% sucrose, weight by volume, is required to prepare 6% sucrose in 100 ml. So we have 100 ml required volume and 6% is the required concentration. And our stock solution has a concentration of 30% weight by volume. We have stock and required equation here, C1V1 equals C2V2, and C1 is the required volume of the stock solution which we need to calculate here. Put in C2, which is 6% required concentration, V2 required volume, which is 100 ml, and C1 the stock solution concentration, which is 30% weight by volume. Putting all these together here, we are getting 20 ml stock solution volume is required to prepare this rice solution. So because we need 100 ml, so measuring flask of 100 ml will be taken, and we will transfer 20 ml of this stock solution into that measuring flask, and the rest of the flask will be filled with distilled water to prepare 100 ml of this solution. So these were the three examples here. I hope you will understand this, and you can also do some practice problems related to dilution concentrations. Our next tutorial, tutorial number 7, is about percentage concentration terms, weight by weight, weight by volume, or volume by volume, and how these concentration terms are calculated, how these solutions are made, and how these percentage concentrations are interconverted with each other. So stay tuned.